Okay, hello everybody, this is Miss Piekarski again. I really hope you watch this video because I'm not going to be in class tomorrow and you will need to know about this stuff to do the worksheets that you have tomorrow. Alright, so we're going to look at polynomials still, and there's two things we're going to cover. We're going to cover how many bends there will be in the graph, and we'll cover what the end behaviors will look like. Okay, with polynomials, sometimes you'll be given a formula and you'll have to figure out what the graph will look like without your calculator. Sometimes you'll have the graph of it and you'll have to figure out what formula would match up with that graph. Okay, well, there's some hints, or there's some pattern with how the ends of the polynomial react and the number of curves or bends or minimum or maximum points on the graph. Okay, the first thing, the end behavior, is what happens to the function as x approaches your extreme end. So as x gets like really small, like negative 1 million or positive 1 million. Okay, so the very end behavior of the graph. That's what we're looking at here. Okay, and so if you did from negative 1,000 to positive 1,000 on your x-axis, and you would see sometimes the graphs, the ends will keep going up like this forever. Sometimes they'll go down like that forever. And we just want to know, we don't care about what's happening in the middle. We want to know, how is the graph going to end up close to infinity. All right, so that's what we're talking about with end behavior. Now, with the number of bends, that's telling us how many relative maximum or relative minimum points are on the graph. There are points at which the graph changes from increasing to decreasing or decreasing to increasing. Essentially, we're looking at the middle of the graph. So if your graph goes like this, you've got one bend here, another bend down here, another one up here, and then another one down here. So the number of bends here would be 4. Okay, if you just had a quadratic formula, then the number of bends would be 1. If you had a cubic formula like that, you could have 2. I know that looks like I have 3, but just because I drew it kind of crazy. Let's see if I can do it like this. All right, there we go. So in this case, we'd have one bend here and another bend here. Okay, so there are certain things that you can tell about the graph and the equation just about the end behaviors and the number of bends. So first, let's look at the number of bends. The number of bends will be at most 1 less than the degree. So if I have the polynomial x cubed, okay, the most amount of bends that I could have would be 2, because it has to be 1 less than whatever my degree is. Let's say I had the degree of 5, then I would have, the most I would be able to have, the most curves I would be able to have was 4. Okay, that's pretty easy. All you have to do is subtract by 1. But then, if our degree is even, then both endpoints point the same direction. They either both point up or they both point down. If our degree is odd, then the endpoints point in opposite directions. Okay, so for instance, our quadratic formula, if I have x squared, okay, my graph would look like this, where both endpoints were pointing up. If I had negative x squared, my graph would look something like this, and both of them would point down. In both cases, both the endpoints are, the end behaviors are the same. They're either pointing both up or both pointing both down. Now, if I had x cubed, okay, the graph would look like this, and one end would be going up and one end would be going down. Okay, so notice our cubed has a odd degree. It's an odd degree, and x squared, our quadratic, it has an even degree. Okay, so that tells us whether, so the even or oddness of our degree tells us if both are going to point in the same direction or in opposite directions. Now, the last thing I want to go over is the leading coefficient. This part, the leading coefficient determines if the graph, the leading coefficient determines the graph right end behavior. If the leading coefficient is positive, the graph points up. If it's negative, the graph points down. So, just from that, I realized that I drew this graph wrong. So the leading coefficient, let's say this was a negative 2x cubed, then because of this negative, the right side of my graph, this side of the graph would point down. Now, let's say I had 2x cubed, so this is positive, then the right side of my graph will point up and the left would point down. The reason why the left has to point down is because it's an odd degree and it's so my ends go in opposite directions. Okay, notice here my leading coefficient's negative, so my end behaviors are pointing down. Here the leading coefficient is positive and they're pointing up. All right, so that's basically the gist. The last page of your notes, you have a table like this, and then you have 4 graphs and 4 formulas on the back. Go ahead and cut out those graphs and either tape or glue them onto this paper. Okay. When you're talking about end behaviors, you'll see some math shorthand. Okay. With your math shorthand, this stuff right here, it reads, as x approaches, this arrow means approaches negative infinity. So this, you're saying on the left side of the graph, f of x, or your y value, approaches negative infinity. So essentially this part right here is just saying on the left side of the graph, the line is going down, and then on the right side of the graph, or as x approaches positive infinity, f of x, or your y value, is going to approach negative infinity. So just from reading this, you could say the graph is pointing down on both sides of the y-axis. Okay, so notice this picture is a quadratic formula, and both the left and the right side of the graph are pointing down. Okay, so this is the math shorthand. This is how you would read it. And then this is a picture of your graph. You do have these 4 graphs in your notes. Just cut them out and tape them or glue them. All right, so this next one, as x approaches negative infinity, y approaches positive infinity. And as x approaches positive infinity, y approaches positive infinity. So basically, on both sides of the graph, your end behaviors are pointing up. And then this one, your left side is pointing down, or it's decreasing, and the right side is pointing up. And then with this one, your left side is pointing up and your right side is pointing down. All right, so these are the 4 different possible scenarios. Now, you need to find the possible equations, or you need to match up the possible equations. With this, let's look at our bends. Because this only has 1 bend, I know that this equation has to be x squared. Because this has 1, 2, 3 bends, it has to be x to the 4th power, or a quartic. It's going to be a quartic function. And this has 2 bends, so this is going to be x cubed. That's supposed to be a 3 there. There we go. And then we have 1, 2, 3, 4. So this would have to be x to the 5th power. Okay, that's what I know just based on the bends. Now, because the right side is going down, this is going to be negative. The right side is going up, so this will be positive. The right side is going up, so you've got a positive function again. And then the right side is going down, so it's going to be negative again. So if you look at the 4 possible equations that are on the paper with the graphs, you should be able to match up the correct functions. We know that this one, the negative 4x squared, would match this. Notice we said it had to be negative. Our leading coefficient had to be negative, and it's squared because I just have 1 bend. And then this one would be something with a positive x to the 4th power. And then this one would be positive x to the 3rd power. And then a negative x to the 5th power. Okay? So that's how you can, you notice that we don't even know what's in the middle of these these formulas. We're just looking at our degree and our leading coefficient, okay? And we can tell whether the graph is going to go up or down. We can tell if one side is going up and the other side is going down. We can tell a whole bunch of information about the end behaviors and the number of bends. All right, so that's the end of the video. I hope you guys watch it for homework and are ready for the work tomorrow. Bye.